Hello guys, today we are going to study physics, a new chapter, that is the chapter number 1 from the physics of class 12 state board. Chapter name is rotational dynamics. Let us know about what is the rotational dynamics. Rotational dynamics is the branch of physics which deals with circular motion and the effect of force to change the direction of the circular motion. So the example for the rotational dynamics is motion of fan, motion of the moon around the earth, motion of the electron around the nucleus. So let us see what is meant by the circular motion. A circular motion is the motion when particle perform the motion along the circular path. Here in the diagram, it is shown that particle A is moving to the particle B and position is goes on changing as the motion is continuously on the circular track. So this motion of the particle is along the circumference of the circle about the fixed point is denoted by the O in the given figure. When the motion of the particle is along the circumference, the position of particle can be represented by a line joining from the center to the position of the particle. Here, the line segment OA is the position vector of the particle A. When particle move from A to B at some time interval, suppose t, so that the radius vector OB vector is the new radius vector for the new position of the particle A, and then new position is denoted by B. So during that motion, the radius vector rotate from OA to OB, makes the angle of theta at the center, that is shown in the figure. It is denoted by the angle theta. That theta is called as the angular displacement. The angular displacement is the angle traced by rotating the radius vector or the position vector during the motion of the particle along the circumference of circle at the center of the circle is called angular displacement, and it is denoted by theta. Its SI unit is a radian. It has no dimension. Here you can derive the formula for the angle theta. Theta is equals to arc upon radius. See here. Here arc is produced. AB is the arc which is created due to the position vector when it rotates. So it creates the arc AB as shown in the figure. So theta is equals to arc divided by radius. Radius means here a position vector, that is OA vector, or you can take the OB vector, and OA vector is equals to the radius. OB vector is also equals to radius. So radius is equals to R. We are denoting the radius as R. So R theta is equals to arc upon radius. Here arc is AB as shown in the figure. So here AB divided by radius R. Here theta is the vector quantity. Here arc is nothing but the small displacement. AB is the small displacement, linear displacement. Small displacement. Here we are writing the arc in the numerator and radius in the denominator. Why? Because this theta is directly proportional to the arc, or you can say the this linear displacement AB. As the theta, that linear displacement changes, the angle also changes. So it is directly proportional. So it is written on the numerator side, and it is inversely proportional to the radius. theta is inversely proportional to radius, so it is written in denominator. So its formula is theta is equals to arc upon radius, so it is equals to AB upon R. That means theta is equals to AB. AB means arc, so it is the displacement that is shown by the S, and the arrow over the S is denoted that it is a vector quantity divided by radius. Radius is also the vector quantity. Theta is also the vector quantity. Suppose particle एक पूरा पूरा का पूरा एक कंप्लीट सर्कल अगर पूरा कंप्लीट करता है, मतलब कि अगर वो यहाँ से ए से स्टार्ट किया उसने, फिर ए से ऐसे जाके, जैसे कि यहाँ पे एक एरो दिखाया है सरकमफरेंस पे, वो उसकी जो मोशन कौन से डायरेक्शन में हो रही उसको रिप्रेजेंट करता है। मतलब ये जो मोशन है ये घड़ी, ये एंटी क्लॉकवाइज मोशन है। जब पार्टिकल ए पोजीशन से ऐसे ट्रैवल करेगा और ए पे आ जाएगा तो एक कंप्लीट पूरा सर्कल उसने कंप्लीट किया। तो ये पूरा सर्कल कंप्लीट करने के बाद उसने अगर लिनियर डिस्टेंस कितना कवर किया तो वो होगा हमेशा सरकमफरेंस के बराबर। और सरकमफरेंस कितना होता है सर्कल का? 2πr। यानी ये पूरा एक चक्कर में ये कितना डिस्टेंस कवर करेगा? 2πr, यानी सरकमफरेंस ऑफ सर्कल के बराबर। इसलिए यहाँ पे फॉर वन कंप्लीट रोटेशन यस की वैल्यू जो है वो कितना है? 2πr वेक्टर। 2πr वेक्टर। Here S is the vector quantity. That's why the arrow is shown over the letter S. As you put the value of S in the theta, then theta you will get 2πr vector upon r vector. R vector gets cancelled. Theta equals to 2π. 2π is the value of theta, and that is measured in radian. So it is in short form, it is written as rad. Rad means radian. So theta is here vector quantity. As we know that in linear motion, the velocity E formula is displacement upon time, and you know that acceleration is what? Velocity divided by time. So similarly, in case of the circular motion, this linear velocity changes into angular velocity, and this linear acceleration A changes by the angular acceleration. Okay, and they are represented with the different letter. Here v is the linear velocity. Okay, in translational motion or linear motion, and this linear velocity is replaced by the angular velocity, that is omega vector, as shown in here. Omega vector is equals to theta vector upon t. Theta vector is angular displacement upon time, means angular velocity is equals to rate of change of angular displacement, that is theta vector upon t. Similarly, angular acceleration is denoted by alpha vector, and linear acceleration is denoted by a vector. So angular acceleration alpha vector is equals to omega vector upon t. Omega vector what? It is vector quantity, omega vector, that is the angular velocity of the particle performing the circular motion. Here omega is angular velocity, alpha is angular acceleration. Now what is the definition of angular velocity? How can you define the angular velocity? And what would be the SI unit and dimensions that we will define the angular velocity first. So it is the rate of change of angular displacement. angular displacement is theta vector. That means its formula is given as here. Omega vector is equals to theta vector upon t. It is the formula for angular velocity. What is the SI unit? SI unit is radian per second. As theta is the angular displacement, its unit is radian and divided by time. Time unit is second. So radian per second. SI unit is radian per second. Its dimensions are in square bracket m0 l0 t raised to the power -1. Why? Because here in the denominator time is there. So when the time is in denominator, then its power will be its power will be -1 when it goes to numerator. So it will t raised to the power -1. What will be the direction of this angular velocity? The direction of angular velocity is given by right hand thumb rule. What is right hand thumb rule? Suppose consider your right hand, curve the finger of your right hands along the direction of the motion of the particle, along with the particle is moving. Outstretched thumb it shows the direction of angular velocity. For the particle moving anti-clockwise, then the angular velocity direction will be vertically upward. When the motion is clockwise, then the direction of angular velocity will be vertically downward. Now let us see angular acceleration, that is denoted by alpha vector, and it is the rate of change of angular velocity omega vector with a time. Its SI unit will be its formula. Let us see formula. Its formula is alpha vector is equals to omega vector upon t. That's why it is called as the rate of change of angular velocity with time. And its unit will be angular velocity. Its unit is radian per second. And again divided by second means radian per second square. So its unit is radian per second square, SI unit. Dimensions in square bracket m0 l0 t raised to the power -2. Why? What will be the direction of the angular accelerations? It is also given by the right hand thumb rule, but here two cases you have to consider. First one, when the particle is uh, moving with the increasing speed, then the direction of angular velocity and the angular acceleration both have the same directions. Okay, for anti-clockwise direction it is vertically upward, and clockwise direction it is vertically downward. But when second case, for decreasing speed, when the motion is decreasing, then angular velocity and angular acceleration both are in opposite direction. So that means to say that suppose the angular velocity, that means to say that when the motion is anti-clockwise, then angular velocity will be upward and angular acceleration will be vertically downward. If the motion is reverse, the direction of angular velocity will be downward and that of angular acceleration will be upward. Uniform circular motion. Any circular motion when speed is constant, then you can say that the motion is uniform circular motion. Non-uniform circular motion, non-UCM. In circular motion, when speed is not constant, then you can say that the motion is non-uniform motion. What are the characteristics of the circular motion? One is accelerated motion, second one is periodic motion. What does it mean, accelerated motion? It means that When the particle is performing the circular motion, its velocity direction is always changing. Second one is periodic motion. The motion of particle is continuously repeating over the same path